Good morning, friends. Thank you for joining me in today's presentation. We continue with our solutions to mapping and functions. In today's presentation, we're looking at how to find the range of any function. In my previous video, we have looked at how we can find the domain, the possible values of x, allowable possible values of x that a function can take. In today's presentation, we want to look at what are the possible values of y that a function can take for that function to exist. Range are all possible values of y that you can have in a function. Let's look at how we can solve this question before us. The question says find the range of the following. We have A, f of x equals to 3x squared minus 5. B, f of x 2x minus 1 in numerator, then x plus 4 in the denominator. As I say, the word range are all the possible values of y that we can have in a function. So, to find the range of a given function, you have to first of all make x the subject of the relation. Let's look at this question. Solution to A now, we have f of x equals to 3x squared minus 5. And we know that y is a function of x. So in place of this f of x, we can replace y because y is a function of x. So we can write this as y equals to 3x squared minus 5. Then we make x the subject of the relation. So to make x the subject of the relation, let's collect like times. We have y now. It will be plus 5 equals to 3x squared. So we have the coefficient of x squared here as 3. So we divide both sides by 3. So we have x squared will be equals to y plus 5 divided by 3. To make x the subject, we take the square root of both sides. Take the square root of both sides. X now will be equals to roots y plus 5 divided by 3. Okay, so what are the possible values of y? That when we plug it into this function, the function will exist. That's the range now. So we have square roots here. If you check my previous video, under case 1, case 2 to 5 under domain of a function, anything you have under the square root or under the radical, it must be greater than or equals to 0. So we have y plus 5 divided by 3 must be greater than or equals to 0. It must be greater than or equals to 0. Okay, so what are the possible values of y now? If it is greater than or equals to 0, then let's solve for y. At this point, let's solve for y. We cross multiply because this inequality sign is acting like equal sign. We have y plus 5 is greater than or equals to 0. So y now will be greater than or equals to minus 5. So the range will be all real number but such that y must be greater than or equals to minus 5. Okay, let me clean here to state that the range, we are asked to find the range. So the range now will be you can state the range because this is the range, any number y greater than or equals to minus 5. So we can say the range now, the range will be y such that y belongs to the set of real number but y must be greater than or equals to minus 5. So this will be the range, or we can use interval notation to state the range. To use interval notation, y is greater than or equals to minus 5. Interval notation, we can say minus 5 is included to positive infinity, not included. So we can use this interval notation to state the range. So the range is minus 5 is included to positive infinity. So from minus 5, minus 4, minus 3, all to positive infinity are included, but positive infinity is not included. So this is the range to this first question. Let's move to the second question. That's solution to A now, or B, solution to B. We have f of x equals to 2x minus 1 divided by x plus 4. We are asked to state the range of this function. Y is a function of x, so y will be equals to 2x minus 1 divided by x plus 4. Let's make x the subject of the relation here. Let's make x the subject of the formula. To achieve that, we can cross multiply at this point. To be y into x plus 4 will be equals to 2x minus 1. Let's clear the bracket. Y times x, that will be yx plus 4y will be equals to 2x minus 1. Those with x one side. It will be xy minus 2x will be equals to, no, let's bring this xy to the other side and leave 4y here. This will be 4y plus 1 will be equals to 2x minus xy. 4y plus 1, x is common, will be x into 2y, 2 minus y. So we can divide both sides by y, 2 minus y, 2 minus y. So that x now will be equals to 4y plus 1 divided by 2 minus y. Okay? What are the possible values of y that this function can take? We'll pick our denominator, that's 2 minus y must not be equals to 0. Must not be equals to 0, because if the denominator is equals to 0, the function will not exist. Then let's solve for y. So 2 now will not be equals to y. So y now must not be equals to 2. So the range now, the range of this function now, the range of this function will be y such that y belongs to the set of real number, comma, but y must not be equals to 2. Y must not be equals to 2. Okay? So we can state this range using interval notation. We can say positive 2 not included, negative infinity not included, combined with 2 not included, but positive infinity not included. We can use interval notation like this. This side means not included. 2 is not included, negative infinity is not included, combined with 2 is not included, positive infinity is not included. So this will be the range to this question. Thank you for watching. Please do share this to your learned colleagues, and don't forget to subscribe to TJ's Maths and Further Maths Adventures. Thank you for watching.